Here's another method where we can determine the population size, where we have to use an indirect method. In other words, where we cannot do a census and directly count because it's a large population and the population might not be easy to count. Now I've got about 80 beans here. I know it's more or less 80. I counted them this morning, but we're going to see what our calculations show us. Of this lot of beans, I put a white Tipex dot, correction fluid dot, on 20 of them. So I did a little bit of work before we started. Now this method is especially suited if you have a population, for example, fish in a dam. You can't very well drain the dam to see how many fish you have. So we use the mark and recapture, also known as the Peterson method. Now, as I've already said, this is my lot of beans, and I marked 20. Ansi is going to assist me, and we're going to do calculations. Now, let's just see before we start what the formula is that we're going to use. To determine the population size, we catch, in other words, I will randomly grab a lot of beans and we will mark them in some way. Now I marked them with a white dot and there are 20 marked. Then we put them back in the dam if they're fish and we do a second catch. And of the number in the second catch, I must count how many of those are marked. And I use this formula to determine, to estimate the size of the fish population. Obviously, the more times I do it, the more accurate or the closer to the real total my numbers will be. So let's get started. Right, we've already have our marks of 20 and I'm with randomly, and I've mixed them as you can see, they were in a little plastic bag. I'm going to take a hand of beans and we're going to count them. I've got 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 beans, Anzi. And of these 25 beans, let's not lose a fish there, or a bean. Okay, I must now check carefully which are marked and which don't have any marks on them. There's another one that's marked. Another one. Beans aren't cooperating very well, are they? Okay, there's another one with a mark. Okay, Ansi, would you believe it? Out of the 25 beans, 4 have marks. Can you do the calculation? How many beans have we got in this sample? 125. Okay, let's do it again. I'm taking a random handful of beans and I'm counting them once more. 1, 2, 3, 4. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Of the 22 beans that I have, it's 20 times 22. 7 are now marked. And now we get a number of 62,8, which we round off to 63. And so we can continue until we get an average that we can be more or less sure of. Now, our two numbers that we had were 125 and 63. Ideally, I should do it a third and a fourth time. not because I know how many beans there are, but because there's such a huge difference. And if my second, third, fourth, fifth number of beans are more or less the same, and this is an outlier, I throw this number away. In other words, this can also be used to determine the size of a population, but the procedures can also be used to prove why investigations should be done more than once to improve the reliability of our results. I know that I have 80 beans here. Just with these two calculations, our average number is 92. In other words, if I do it more and more and more, I will get closer to 80. But remember, in real life, we don't know the exact number, and that is why we have to do it several times to make sure that we get as close to the real number as possible.